Okay, let us discuss this problem. So this is related to finding the electric flux through a circular area. So we have a circular area here of radius r. We have to find electric flux. Let me read the language of the problem. So this says a very long uniformly charged thread is oriented along the axis of a circle of radius r. So this is a very long thread. So I can assume this goes up to infinite. So this side, this goes up to infinite. But this side, one is at the center of the circular area. This is charged. Radius of this circular area is capital R. The charge of thread per unit length is equal to lambda. So lambda is the charge per unit length of this thread that is given to you. Find the flux that passes through cross-sectional area E, cross-sectional area of circle. So what is the flux that passes through this cross-sectional circle? So you see, these are the charges. If you consider each charge will have some flux that will flow, I can separate this problem in a small problem first, and then we'll do this one. So if we have a circular area, and now let us say on axis there is a charge q. So let us say there is a charge q that is kept. What is the total flux? What is the total flux that passes through due to this charge through this circular area? So how will you calculate? Now if I apply the Gauss law, I know the total flux that is radiated through this charge passes through an angle of 4 pi. So this passes through an angle of 4 pi. This is also this side. Now only some part of the flux passes through this circular area. Now if I somehow I know what is the solid angle subtended by this circular area to this point, I can use the unitary method. So solid angle subtended by this ring on this charge is 2 pi 1 minus cos alpha. This we have discussed in the class. So let us say this is your ring and this is your charge here. So solid angle subtended by this circular area, so let us say charge is here. So solid angle subtended by this one, if this distance is x, this is radius r, that is basically fixed. So solid angle subtended by a ring onto a charge, a point charge p, is given by, this we have derived in the class, 2 pi 1 minus cos alpha. So this angle is alpha, 1 minus cos alpha. Are you getting or not? Where alpha can also be written as, so if you want you can write alpha in terms of x also. 2 pi 1 minus cos alpha is this distance divided by this distance, that is x by under root r square plus x square. So if you wish you can write in terms of this also. Basically you remember 2 pi 1 minus cos alpha. Now see, this solid angle you can always remember, if alpha is 0, that is cos alpha is 1, so solid angle subtended is 0. If cos alpha is minus 1, that is alpha is pi, solid angle subtended is 4 pi. Minus 1 of minus plus 1, and 1 2 into 2 pi 4 pi. So when solid angle, so this means if I increase the alpha, when alpha becomes pi, this subtends the whole sphere. That's why in that case solid angle is 4 pi. Now you have to remember this result, solid angle subtended by a circular area at point P is given by 2 pi 1 minus cos alpha. Now I will use this one. So if I have a charge Q here, so Q charge, if I apply the Gauss law, so total flux radiated by the charge Q will be Q by epsilon naught. So total flux by Q total flux, everybody knows E dot ds integral is Q by epsilon naught. Total flux will be Q by epsilon naught. Now this total flux passes through a solid angle 4 pi. So now I can use unitary method. When 4 pi is the solid angle, my flux is q by epsilon naught. Are you getting? So this means if I have 1 unit is my solid angle, if 1 unit is my solid angle, so the flux will be q by 2 pi epsilon or 4 pi. So this is 4 pi epsilon naught. So let me write this is 4 pi epsilon naught. And what is the solid angle? 2 pi 1 minus cos alpha. When my solid angle is 2 pi 1 minus cos alpha, what will be the flux? So this will be q by 4 pi epsilon naught into 2 pi 1 minus cos alpha. Are you getting? 2 pi 1 minus cos alpha. So this 4 pi goes, so we will have q by 2 epsilon naught. So I can write here, so q by 2 epsilon naught 1 minus cos alpha. So this is the solid angle subtended by a point. So flux passing through the due to the point on a ring. So this is a flux. Now you will use the same result to solve the above problem. Now in this case what we have, so in this case, so the above problem, so there is a ring. So let me make the ring first. So I have ring, and then I have this infinite wire. Now what we will do is, let us say at a distance x, or basically I will not need x. Let us take a small charge dq. So this distance is dx. So charge on this part of the line will be, so dq will be lambda into dx. Are you getting? Now this angle, so I need this angle. So let me make this one first. So if you can do yourself. So let us say this is the angle alpha. Are you getting? So you can copy. This length is a, x, this length is radius r. So you can always put this as a radius r. So this length will be under root r square plus x square, or you can work in terms of alpha. So now due to this point charge, the flux will be same, that is q by 2 epsilon 1 minus cos alpha. Alpha is the angle. So let us say a small flux will be dq. So charge dq will be now dq. dq is nothing but lambda into dx by 2 epsilon naught and 1 minus cos alpha. Now I have to do integration. Are you getting? So let us copy this one first. Okay, let us do this integration and finally we put the limits. So let us say this is lambda by 2 epsilon naught and 1 minus cos alpha. So I will have 1, and cos alpha is what? Cos alpha is nothing but x divided by under root a square plus r square plus x square. So this is x square plus r square. So if I plug this value here, 1 minus x by under root r square plus x square. Now dx will be also here. So for doing this integration, I will need some substitution. So let us do substitution. X is equals to r tan theta. So what will be this term? So r square plus x square will be, that is r square plus x is r tan theta, r square tan square theta, and this is 1 plus tan square theta is sec square theta. So this is simply r square sec square theta. So root of r square plus x square is, this will be r sec theta. Are you getting? Now for dx, so I have x is equals to r tan theta. So dx will be r tan theta, differentiation is sec square theta d theta. If I plug these values in the given integration here, if I plug these values, so I will have lambda by 2 epsilon naught. I think you are able to see this one. 1 minus, and this is x. X is r tan theta, so I will have r tan theta on the top. And root of this is r sec theta. So we plug the value r sec theta here. So you can remove this space. So we will have r sec theta here. And what is dx? Dx is nothing but, you see here, r sec square theta d theta. So r sec square theta d theta. So this will be lambda r by 2 epsilon naught 1 minus, so this is sin theta by cos theta sec theta 1, so this is simply sin theta into sec square theta d theta. Now if I multiply more, so I will have lambda r by 2 epsilon naught, and this is sec square theta minus sin theta by cos square theta. So sin theta by cos theta tan theta, so sec theta tan theta, sec theta into tan theta, and this into d theta. Are you getting? So I will have, now we can separate two integration, lambda r by 2 epsilon naught, and then you will have one integration sec square theta d theta. So let us first do the indefinite integral, minus sec theta d theta, sec theta tan theta d theta. So you will have two integral. Now this is lambda r by 2 epsilon naught Now integration of sec square theta will be tan theta, because everybody know differentiation of tan theta is sec square theta. So integration of sec square theta will be tan theta minus, so this is differentiation of sec theta. Differentiation of sec theta is sec theta tan theta, so this is integration will be simply sec theta. So this means if you want to write, you can write lambda r by 2 epsilon naught. This is sin theta by cos theta. So sin theta by cos theta, and this is sin theta by cos theta minus 1 by cos theta. So this is simply as lambda r by 2 epsilon naught cos sin theta minus 1 by cos theta. I think all of you are able to see this one. So if I go back to our original variable, that is x is equals to r tan theta, so basically I sorry, x is equals to r tan theta. So if I go back to the original variable, let us take this equation. This is a better way to write, so no simplification. So if I plug the value of tan theta and sec theta in this equation, so I will have, so x is equals to r tan theta, so this means I have tan theta is this is x, this is r, and this is root over x square plus r square. So this means tan theta is simply x by r, but sec theta is equals to, sec theta is this divided by r. So if I plug these values, so I will have lambda r, so I am writing from here, so this is lambda r by 2 epsilon naught, tan theta is simply x by r, and sec theta will be, you can check your copy here, that is x square plus r square divided by r, under root x square plus r square divided by r. Now you can cancel r also, So this will be lambda by 2 epsilon naught x minus under root x square plus r square. Now we have to put the integration limit. So limit of integration will be from 0 to infinite, because this wire is infinitely long. So you see in the first part we said, and this wire is infinitely long, so x will go from 0 to infinite. So if I put this limit 0 to infinite, I can find out the value. Now important point is, if I have infinite, this value is infinite minus infinite. That is slightly difficult to find. So let us find first. So this is what I have to do is, I have to first find lambda by 2 epsilon naught, and let us say this is a function f. Function value when infinite, x is infinite, minus function value when x is 0. Let us see function value when x is infinite. I will use the expansion method. So I have function fx. This is x minus root over x square plus r square. Now let us take x common. So I will have 1 minus under root 1 plus r square by x square, and x is much greater than r. This means this term is 0. So now I can expand binomially. So if I expand binomially, so this becomes 1 minus 1 plus nx. So this is 1 plus n is 1 by 2. X is nothing but r square by x square. So now this term will be x 1 minus 1, that is 0. So minus half r square by x square. Are you getting? Now this is, x will be cancelled, so you will have 1 r square by x. Now x goes to infinite, r is a finite number, so this term will go to 0. Are you getting or not? So because x tends to infinite, so if I have limit x tends to infinite, this term will be 0. R square by x, because r is a finite number, x is an infinite number, so this will be 0. The function value at 0 is very simple. So fx when x is equals to 0, and this value is very simple. You simply plug this value, x is equals to 0, so 0 minus x is 0, r square, so 0 minus under root 0 plus r square, so this is simply minus r. Are you getting or not? Now if you plug these values here, so you will have finally lambda by 2 epsilon naught. So this is lambda by 2 epsilon naught you will have into function value at infinite, that is function value at infinite minus function value of 0. So function value at infinite is 0 minus function value at 0, that is minus r. So this will be the, finally will have lambda r by 2 epsilon naught. Are you getting or not? So this will be the final flux you will have in this situation. So this is a quite good problem. So if somebody says find out the flux passing through one point, then you have to use the concept of solid angle. And if somebody says find out the flux due to the line charge half infinite, then you have to integrate this point charge from 0 to infinite. Are you getting? Now what will happen? Let me discuss. If I have this charge, this line charge this side also, I have this charge this side, and if I have this line charge this side also, this say both side I have line charge, what will the final result? Can anybody tell me? So this means what I am saying, you have this charge only this side in this question. Now if I have same charge this side also, so what will be the total flux passing through this ring? Either this result will get doubled or not. No, in this case the total flux will be 0 because some flux is passing through this side, but the same flux is passing through this side. So total flux will be 0 in this case because some flux is passing through right side, some is left side, so total flux is 0. But if you have a negative charge this side, in that case it will be doubled. Now if somebody says, I have positive charge this side, but I have negative charge this side, in that case result will get double because this will pass the flux this side due to negative charge, some flux that will come from infinite that will pass through this side. So in that case result will get doubled. Are you getting or not? We'll discuss the next problem.